Okay, well, we had another last-minute room switch because of technology issues, but here we are. And everybody had a great spring break, I hope. Winter break, whatever we call it. And you have a homework assignment due today, right? And it is a program, right? Okay, so I've already had some people come by with questions, so let me give you the information that came up. Here's the thing. What you have to do is write a program to use the direct code implementation of a finite state machine to recognize a hexadecimal value. And the question that came up was, how do we do the finite state machine? And I intended for this finite state machine to be very simple. Let me just draw it. So here's the start state, and all you have to do is on a hex digit, go to the final state, and on the final state, stay on the final state with the hex digit. That's all there is to it. Do the finite state machine. So what you might be tempted to do is have one transition on lowercase a to lowercase f, and another transition on uppercase a to uppercase f, and another transition on 0 to 9. But just consolidate everything into one hex digit. And also, by the way, I got your homework, your programs back from your previous assignment, and I put comments on there about how to do this program. So check over your comments. Some people did things a little awkwardly or suboptimally, and so you need to correct those. Maybe you might have to correct your approach to do this homework assignment. Okay, and here, while we're on that, here's what I recommend. In this implementation, this direct code implementation on where we implemented here in figure 7.20b, we implemented this signed integer, right? And notice here that in this part of the figure we have, in the parser we have private Boolean is digit. So what I recommend you do is have private Boolean is hex digit, and put all of your code that you need to detect whether it's a hex digit in that. And here's another suggestion that I have. Here, later on in figure 7.29, you see where in case s underscore f, take it back, in case s underscore m, look at the computation if is digit next char. So your code should be if is hex digit next char. And you see where we say number gets 10 times number plus numchar minus 0. What I recommend you do is, of course, instead of being number gets 10 times number, what would it be? 16. Yeah, it would be 16 times number. But here's what I recommend. Instead of doing next char blah, 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 write another function whose precondition is that the character is a valid hex digit, so you don't have to check for it. In other words, you see what I'm saying, with a precondition, and have all that logic for returning the value of the hex char in that one function. And then this will still just be a one-liner. Now, is everybody with me on this? So I know, there's a tendency to have code scattered all over the place and have all kinds of computations, but consolidate it all into a few functions. Yeah? Is everybody clear on this? So what this line could be? It would be number gets 16 times number plus, I don't know, what would you call it? Something like hex digit value or something like that. That would return an int. And its precondition would be that it's a valid hex character. You could assume that because you'd be checking that with the previous function before you call it. See, in the if statement there, you see. Is everybody with me on this? Any more questions? All right, good deal. So now, today, what we are going to do is we're going to start we're going to give you a program, and it's going to be the model for the first milestone of your big project. Now, get this, you guys. What are the three aspects of translation. Do you remember what the 3 stages of translation are? Ah, excellent. Lexical Analyzer. Here it is in figure 7.27. Next one is what? Parser. And the next one is what? Code generator. Your Lexical Analyzer is due a week from today. This is your first big milestone. And in fact, it's a big project, so the assignment for Thursday is to start working on the next assignment. All right? So now you have a whole week to do this. So everybody, are we good? Okay. So this is the first, so a week from today is the first big milestone, and it's to write the Lexical Analyzer for your translator. And so what we're going to do today is we're going to show you how, we're going to give you techniques, show you how to do that. All right, starting today and tomorrow. All right, so everybody good? So so now let's do it. So to show you the techniques that you will need in order to do this part of your project, let's take a look at a multiple token parser. We're going to implement a multiple token parser. And here in figure 7.31 is the finite state machine that we are going to implement. So let's study this for a few minutes. Now check it out, you guys. First of all, what do you notice about the start state? It is also a what? It's also a final state. And how can you get from the start state to the start state with a space? Are you with me? So what this means is that the start, if you have a line, an empty line that has nothing but maybe a few spaces, maybe not a few spaces, that empty line is going to be recognized. And the token that's going to be recognized in that situation is called the empty token. All right, and this is how the finite state machine is going to handle leading and trailing spaces on a line. All right, and now what about from the start state to an ident? That's the transition is on a what? A letter, and then from ident to ident is on a what? A letter or a digit. So obviously the ident state is recognizing a what? Identifier, yeah. That starts with a letter and has a letter or digit. Is everybody clear? Is everybody good? And now what about the int? How can we get to int? By digit directly, or what? A plus or minus to a state called sign, and then a what? A digit from sign to int, and then a digit on int. So this multiple token, so this is a multiple token parser. What this multiple token parser is going to recognize is either the empty token, or an identifier, or a signed integer. All right? And the techniques that we're going to use the direct programming technique to implement this finite state machine. We'll give a demo here in a minute, but here's another idea that's going to happen with this machine. The parser that we're going to illustrate here is line-oriented. So what it's going to do is it's going to recognize all the tokens on one line, and then at the end of the line it's going to recognize the empty token. So the empty token will be recognized at the end of each line. And if the line itself is empty, that line will just be recognized by the empty token. All right? That's the idea. Now to show how this works, I think the best way to do this is to show how this works with a demo. So before we'll do a code walkthrough in a minute, but before we do the code walkthrough, let's do a demo. Okay, so now here's going to be our demo. I won't show you the code for figure 734 because we'll do the code walkthrough with the slides in a minute. But let's just run figure 734 and let me show you what happens. So here, if we do run, check this out. So up here, here's our dialog box. Now one thing you notice about this is that it's multi-line. Okay, so before we just had a single line of input, but now we have multiple lines of input. And not only that, what does the button say? It says parse. So now what happens is, I'll just do a few little random ones here. Let's do here, space, plus 56, space, space, minus 9, return there. And let's parse this and see what happens. Now look what the output said. Do you see how it identified everything? First of all, it said identifier equals what? Here, integer equals what? 56. Integer equals -9. And then what was this empty token? The empty token was happened because of why? We're at the end of this line. See, look, there is no space at the end of that line, but it recognized the end of that line. Now, is everybody clear on that? And then here, I said here, it's there. And so here is there. Identifier, so identifier goes there and empty token. That's the empty token at the end of this line. Now look, if we had put a new line here, or maybe a couple of new lines here, and if we, just to separate this, and now if we go back and parse this, watch what happens. Now what's different about this is we have some empty lines there. And see how for each empty line it put empty token. Does everybody see how that works? The end of each line is always, it always detects it returns the empty token. Are you with me? Now, to show you a more complicated example, I have here some text. All right, that I pre-typed because I didn't want to have to type it. So here, let's copy this, and let's come down here, skip a few more lines, paste this into here. So now here is A47, 48B, no, is that, yeah, 48B. Now notice there's a leading space, okay, and then there's a leading space here, C-49, A long identifier, that's blah, 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 blah. Let's parse this and see what happens. And check this out. Identifier equals, here is A47. Now look at this 48. It's up here, it's 48B. How did that recognize that? 48 and then B, and then the empty token at the end of the line. Okay? And so, I have a slide with this on it. We'll look at that in a minute, but I want to just demo one more clipboard. Check this out. Now this one has some errors in it. Can you spot the errors? Or an error, maybe I should say. Can you spot the error in that? Yeah, there's a plus here, but then there's a space before the 48. Right? Does everybody see that that's going to be a syntax error? And let's see what happens with a syntax error. So here, let's get some more space here. Oops. So let's parse this. And look what happened. It said identifier equals here, identifier equals is, A47, and then what happened? Syntax error. So you see in a translator you have to take account that the user might have an erroneous input. So we're going to have to program how to handle errors. Yeah, I meant the plus before, yeah, it's the space after the plus that caused the error. That's what I meant to say.
Oh, okay.
Yeah, now see, that's a really good way of putting it. If they're mushed up together like the 48B, it was able to work. And that's a big deal in parsing. We're gonna, yeah. So I have some slides on this. We'll take a look at it. We'll take a look at that now. Okay, so that ends our demo. Okay, so the demo that I just gave actually is here on figure 7.32, and it's in the book. So let's go through here in a little bit more detail and figure out exactly what happened, and then we'll do a code walkthrough and see how it happened. Now check this out. As we see on the slide, here, and then a space, so the identifier equals here, is, identifier equals is. Now look, the A47, the 47 was after the letter A. So it recognized A47 as a single identifier. Is everybody with me on this? Okay. But then what happens, what comes next is 48B. So the 4, when it sees the 4, that detects the what? As a digit. You see? And then the 8 is another digit. And then the B, what happened with the B? Well, that's no longer part of the token. So look, here's what's going on. In this figure 7.31, this multiple token identifier, you see that what's happening is we are scanning a line, And each time we scan a line, we look at the next, we detect the next token. We detect the next token. But then what happens is, after we output that we have detected that token and we return that token, what happens is, we start over at the start state again of this finite state machine. Now, is everybody clear on that? We're invoking this finite state machine continuously as we go through the line and are detecting strings of tokens. So are we good? So we always start back at the start of the start state. So let's think about that 48B. So the 4, starting at the start state, the 4 will take us to what? On digit, it will take us to int, and then the what? The 8 will do what? On a digit will take us to int. But then what will happen with it? We'll be in state int, and then what will we detect? The B, hold on. The next character will be a what? A B. But what state are we in? Int. So is there a transition from int on a B? Yes or no? No. So what has to happen? Because there's no transition from int on a letter, but we are in a final state, what have we done? We have detected a what? And we have detected an integer. Now, is everybody clear? Because we are in state int with the 8, and we got a letter coming up next, there is no transition from int on that letter. So, but we are in a final state. Are you with me? We are in a final state. So what have we detected? We have detected an int. But what do we have to do with that B? Yeah, we have to scan it again. Now, how are we going? That's really good. How are we going to scan it again? What we have to do is we have to wait to do. What do we have? Because we're going to start over at the start state. So what do we have to do with that B? We have to do what? Back it up. We've got to back it up. So that when we start at the beginning of our start state, the B will take us to where? To ident on a letter. And then there's nothing after the B, so there's no letter or digit, but then we have recognized the identifier. Now, does everybody see that backup concept? That is kind of like a crucial idea on how all of this stuff works. Are we good conceptually here? Okay. All right, so continuing on here in figure 7.32, so we detect the D, and now why do we have an empty token? Because we are at the end of that line. Because what happens is, when we get the B, after we scan the B and we recognize an identifier, if we restart the finite state machine, where are we? We're in the start state. And do we have a transition? There's no space, there's no letter, there's no digits. So what happens? We have recognized the what? The empty token. Okay, and it's going to be the new line character that tells us that. Because there is literally a new line character at the end of each line. Are we good there? Yeah, question? No. The new line is at the end of each line, not at the end of each token. And now look, this C-49 on the next line. The hyphen is right next to the C, right? So what did we do? When we started the finite state machine over again, when we started the finite state machine for that line, there was a space that took us to start. And then there was a C that took us to where? Ident. Yeah, to the ident state. And then there was a what? A hyphen. But is there a transition from ident on hyphen? Yes or no? No. So, but we are in a what kind of a state? We're in a final state. So therefore we know that what? We have recognized the token, an identifier token. And what do we have to do with that hyphen? What do we have to do with the hyphen? Back up the input. So that when we start over the next time around, that hyphen will take us to where? Sign. Yeah. Now, does everybody see how this works? This is classic tokenizing. This is the way it's done. Is everybody? Yeah, question? Ah, that's a really good question. Suppose you had, so the question is, why aren't the spaces included in an identifier? Because what happens is, if you have space, 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 here, space, what will happen is, this space will take you from the start state to the start state. This will take you to the start state. This will take you to the start state. This will take you to ident. So those spaces never stop, you see? those spaces got gobbled up. They got consumed by the design of this finite state machine and the start state, because there's a transition from start to start on space, and you will just keep making that transition, boom, boom, boom. But then when we get to the H, that'll take us to the ident. The only thing that will let us stop when we're in the start state is just a new line by itself, or space, 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 and a new line. Is everybody? Yeah, question? It did go. It pushed. Oh, that's a good question.
Yeah, because there's no change.
Yeah, because there's no. Yeah, that was a good question. So what happens is here. Yeah, let's do here. C plus 49. So let's do the scenario here. This scenario. So let's go back to our finite state machine. All right, let's do space, space. All right. So here we're starting. We start at the start, right? Space. This space takes us to what? Start. This space takes us to what? Start. This C takes us to what? Ident. We're in state ident. We scan the plus. Is there a transition from ident on plus, yes or no? No. So, but we are in a what kind of a state? A final. Therefore, we know we have recognized a what? An identifier, a token, the identifier token. And what do we do? Well, no, before, yeah, we do that, but what do we do also? We back up. See, we scanned this plus, so now we back this up so that the next time around, the plus will be there.
So you only go back and scan it again if you're in a final state?
Yes.
Because that's what I was asking with the plus at the end. It's just.
Oh yeah, if you got rid of the 49, it was just this.
Yeah.
Here's what would happen. We would scan the C, we'd be in ident. We would scan the plus. There's no transition on plus. So we would back up the input here and say that we recognize this C. Then we would start over, and we would be in the start state. Are you with me? And there would be, and now we have a what? Plus. A plus. Is there a transition on plus from the start state?
Yes.
So it would take us to where?
Sign.
To sign. Now we're at sign. Now what happens?
Error. Is there not a final state?
No, well, okay, suppose there is a space. What would happen? Then, then there's no transition from sign, and we are not in a final state, and therefore it's an error. Okay, so does everybody see how this works? Now the other thing that we want to, before we go on and take a look at some code, start doing some code walkthrough, is let's take a look at, let's review what happened when we had a syntax error. The way this works, the way this, and the way your multiple token recognizer is going to work is it has to be able to gracefully handle errors with meaningful error messages for the user. So the way it works is this illustrates the way it works. The error was the space after the plus in this figure 7.32, the second part of it. All right? So what happens is it goes ahead and outputs all of the tokens up until the error, and once it hits the error, it ignores the rest of the line, even though it might have valid tokens on it. Because once you hit it, once you know that the line is erroneous, that there's an error in the line, then it just skips the rest of it and starts over with the new line. All right? It identifies it as a syntax error and starts over with the new line. Does everybody see that? That's just to observe the behavior of this parser. Are we good? Is everybody good? Okay, now, with that in mind, now it's going to make sense to see the code for what we're going to, for this input buffer, okay? So now, this input buffer, and by the way, I have written this input buffer for you, and this is the input buffer that you will use in the project in your first milestone, and you will also use it, you will continue to use it in the next stages of your project, okay? So this is, this I've written for you once and for all, and we can just use it. It's error-free, guaranteed, bug-free. Okay, so what does it do? It's used to process one character at a time from a Java stream as if it is from an input stream. So you know how with these finite state machines we conceptualize the cursor going boom, 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 boom. Okay, so this input buffer is going to, it's going to take the whole string from the, it's going to take the whole string from the dialog box, and it's going to break it up into lines, and it's going to be able to scan one character at a time, and it's got to have the ability to do what? To back up the input. So we're going to program that into our buffer. All right. So it provides a special feature needed by multiple token parsers, namely the ability to back up a character into the input stream after being scanned. Does everybody see, now that we've seen how they work, does everybody see why we need to do it this way? Okay, well, I have to build in this feature. Now this is really slick, you guys. I think you're going to like this code. This is really neat. Watch this. Okay, so it's public class in buffer. All right. And here again, another question that that I answered earlier today on the homework assignment is how do you store your different classes? And remember, in Java, each class has its own file named the same thing. So you need to that. I zipped up a NetBeans project folder. And if you unzip that, if you expand that and then open it up in NetBeans, you'll see that there's only one file. But you're going to have to add, each time you have a class, like the state has to have its own class, you have to have a separate file for that. Yeah? Okay, like we demoed before. All right, anyway. So here in figure 7.30, the point is that this public class in buffer is going to be in its own separate file. And now, what are the attributes? Private, string, in string. So does everybody see what that is? That in string is the whole, that's all the lines of code. Are you with me? All the lines of code. Because we had multiple lines. Are you with me? We had multiple lines of code. Okay? And what do you suppose line is? Also of type Java string. It's one line. Is everybody clear on that? Because we process this one line at a time. Okay? So, and what do you suppose line index is, which is of type int? It's where you are in that line. So if this is the start line, this is what? Line index is 0, 1, 2, 3, etc. Are we good with that? Okay, so those three, in string, line, and line index. That's all we need. That's all this. Those are the attributes of this buffer. All right. And now, you guys, in public in buffer. What is the name of this method? In buffer. What is the name of the class? In buffer. A method with the same name as the class is the what? Constructor. So does everybody see? Anytime we do a new buffer, what's going to happen? It's going to call this. And what's it going to do? In string gets what? String plus what? 2 new lines. Because we want to guarantee that there is, first of all, that if the user puts one line of code in and doesn't put a new line character in, that there is at least one new line at the end of that line. And furthermore, the last line is a single new line character. Does everybody see? So this is going to guarantee that. So now when we process in string, we can guarantee that the last line is a line of 0 length. Even if the user doesn't put any new, even if the user has one line with no new line character at the end, we're going to append it so that we can guarantee that that's the case. Now, are you with me on this? So the code, the loop that we're going to use this buffer this guarantees that we can terminate our loop correctly when we use this in buffer. All right. And now look, you guys, here's the code. Look how simple this is. First of all, we have a method called getLine. Now let's take a look at this code and see if we can unravel it and see what getLine does. Public void getLine. So if the program calls getLine, what does this getLine do? It says what? Index I gets what? what does it say there? In string, so that's the whole many lines, dot index of what? New line. So what that does is that starts at the beginning of that multi-line thing, and it's a Java index of is a Java method for Java strings, and it finds the position of the first new line character, which is going to be the end of the line of the first line of that multi-line. Is everybody clear? And that's what I is. And now what do you suppose this is? Line gets what? In string dot what? The substring from where? From 0 to the new line plus 1. So what does it get? So now what does line have? All the content of the what? Of the first line in where? In string. Are you with me? But now what are we going to do to in string? Now what are we going to do to in string? Get rid of the first line of in string.
Well, get rid of, wait.
Yeah, we're going to get rid of the first line of in string.
Oh, like delete it.
Yeah, well, yeah. It's when you say substring I plus 1, that's from I plus 1 to the end. So everything but the first line. So in string is going to get everything but the first line of in string. So you see what we're doing is when we do inline, we peel off. We take the first line of in string, we put it in line, and then we peel it off. So each time we do inline, we peel off another line. We peel off another line, peel off another line. Is this slick? Is everybody clear on this? How that works, what that's doing? And then what do we do? One more thing. After we strip off the front line, what do we do? And this gets 0. So now we are positioned at the start of our first line of the sequence of characters that we need to scan. Are you with me? Is everybody, are we good? Okay. And now, what is Boolean input remains? It checks to see if there's anything left. In string dot length not equal to 0. Right? So everybody, the length, so if the length is 0, there's none left. We peeled off the last line and there's nothing left. So length is a Java method for Java strings. In string is a Java string. Is everybody clear? Okay. And now, what is advanced? First of all, what does advanced input return? A character. And what character does it return? Line dot what? Char at sub what? Line index plus 1. So it takes the character at the index. So if our index is here, if our index is 0, 1, 2, what does it do? It returns the C. So line index would be 2, like 0, 1, 2, right? And so if line index, so it returns line index dot character. So it returns the C, but as a side effect, what does it do? It increments line index so that the next time we do an advanced input, it will be pointing to the next one. Is everybody with me? And now comes our super duper feature. How do we back up input? Line index minus minus. Is that slick? Is that cool? All right? All right, sports fans. Now let's take a look at some of the data structures that are going to be involved in this tokenizer. Figure 7.33 now is our class UML class diagram. And what does it look like we have here? What do you suppose a token stands for? An abstract token. Notice that it's slanted, font, abstract. And furthermore, what single method does it have? Get description. And the plus means what? Say it again. Public. That's UML terminology for public, right? So everybody, you remember your UML diagrams? Okay. So public, get description, and what does it return? Type what? Type string. So that string that it returns is, let's go to this previous figure. That string that it returns is, yeah, it would be here. Yeah, so it would be, in this case, for the first token it would be here, for the second token it would be is, for the third token it would be A47. Yeah. Okay, so that's the purpose of get description. And now, how many subclasses do we have? We've got 4 subclasses. T empty, so we know what that is, right? That's at the end of each line. And now what's the second one? T invalid. So what happens is if we have an error, like a plus after a space after a plus, we have to return some kind of token, so we will return the invalid token. Is everybody with me on that? So return the invalid token. And then T integer. Now, not only does this tokenizer parse integers, it also does what on the fly that we saw last time? Converts the string of characters to a what? Not only does it say plus 94 is valid, it also does what on the fly? It converts it to an int value. Okay, so that int value of type int is the integer value of the string plus 94. So the int value is 94. So this is the string, this is the int value. So it does that by multiplying by 10 each time, you know, it goes through the loop. Same technique we used before.
But when it
No. Well, okay, that's a really good point. The question is, what happens when we print it out for the output? The answer is, we are going to store it as an int, and we are not going to remember the string of integers that it came from, and we're going to let Java print out the string of characters that correspond to the int value 94.
and that's what the
Yes. Yeah, we'll see the code. Is everybody okay? And then what else does T integer have? All right, so now let's take a look at T integer and T identifier. T integer has a method called T integer, which is the same name as the class. So that T integer must be a what? A constructor for the T integer class. All right, and the T identifier also has a method called T identifier, so that T identifier must also be a what? A constructor. Now, do you see that the parameter for the T integer is an int? The parameter for a T identifier is not an int. What is it? It is of type string buffer. Now let's close with this fact. So here's some Java info. Now do you guys remember the difference between mutable and non-mutable, immutable from data structures? What's mutable versus immutable? Mutable means you can change it. Immutable means you cannot. Okay, so you need to know this. This is important Java info. So let's say Java string type. So the Java string type is immutable, cannot change. Cannot change. Safe, but slow. All right? Java, well, what's the other one? Java what? What's the other type? Okay. It's mutable, okay, which means you can do what? Can change, all right? And it's dangerous, but what? Yeah. And that's always a trade-off, you guys. This is good software engineering principles. All right. So I think what we'll do is we'll continue this discussion at the beginning of class next time.